So today we're going to just briefly introduce chemical reactions. We've already talked in terms of chemical reactions a little bit throughout the year, including some net ionics with the summer materials and right there at the very beginning of the year. But we're going to continue on with that today. And to kind of address net ionics, you've got to really have a good handle on the dissolving process. So if you would take an ionic compound, dump it in the water, if the material is soluble, it'll break up into ions. And no, you don't always have to think about these as a chemical reaction, but it does kind of help with stoichiometry. It helps with other things that we're going to talk about with chemical reactions if you kind of know how these things break up. So it's a 1 to 1 to 2 relationship with this particular one with calcium chloride. If you would have aluminum chloride, it would be a 1 to 3 ratio. So that can have significance if we're dealing with something with chloride. And we will be thinking about those kind of things as we move on through the year. So we've talked about how this dissolving happens, and so water has the ability, because it's so polar, it has those partial positive and partial negative ends that can actually pull many of these ionic compounds apart into their ionic components. If you have an ionic compound that dissolves in water, you would have a strong electrolyte. If you would have a weak acid, it's going to only partially dissociate into its ions, and so we're going to give it a double arrow, and that signifies that most of the compound does not break up, just a little bit breaks up into ions. As we go through the year, closer to the end of the year, we'll actually quantify how much of these weak acids or weak bases dissociate. And then of course we've talked about non-electrolytes, compounds that dissolve in water but don't give you any ions, and we certainly won't spend as much time on those as the strong electrolytes, but still they're important. We have a bunch of different types of reactions, and we'll study each of those or some of these in more detail. Precipitate reactions, we can use those in a lot of different things. A lot of stoichiometry questions that you've done in first year chem dealt with precipitates. To know what is the precipitate, what's the soluble, you have to know solubility rules. And I highlighted a few in red here that I think if you know those ones, that's going to get you through most of your questions. I'm not going to get through all your questions, but so those, I think, 4 are going to be much more important than the rest of them because you run into those a lot more. We've talked a couple times already about polyatomic ions, and there's no way around it. You do have to memorize these. And if you get to the bolds, I think that's going to be the ones we're going to use for the majority of the year. Those other ones we will run into, but not nearly as common. We've talked about net ionics. We've talked about spectator ions already. Spectator ions are the ions that would get canceled, so you never get to see them in the net ionic equation. They are not truly in the reaction. They're kind of along for the ride. You can't go get ions in the stockroom. Typically, you have a solid material, and it's going to contain cations and anions in dry form, and one of those is going to be the important one, and the other one's going to be the spectator. You went over this in last year in chemistry. Probably didn't do much in the way of labs with this, but typically if you see these things occurring, those are good giveaways that a chemical reaction is occurring. So formation of precipitate, bubbles forming in the when you combine two aqueous compounds, so forth. Does that mean that all these things are always signs of chemical reactions? No, but typical. And I wrote down a number of sort of common styled chemical reactions that we're going to kind of see. And then I put together like kind of a generic of these. And some of these you've learned already last year, some you didn't learn. You learned maybe the word synthesis or decomposition or double replacement. But like for instance, in double replacement, you can have precipitate reactions that form a precipitate, or acid-base neutralization reactions that typically are hydronium plus hydroxide making water. But I listed a few other ones, and I don't know if you noticed, but there are a few common, I mean, we don't have too many here, but we had water and carbon dioxide here. Maybe I should have circled those actually in here. Not always, but it seems that for the most part, if you have the possibility of forming water will often be formed. If you have the ability to form carbon dioxide, often you will form carbon dioxide. It's not as typical, but if you have the components to make sulfur dioxide, often you will make sulfur dioxide. Those chemicals are fairly stable chemicals, and there's a couple things that drive chemical reactions, and that's one of those things that drive chemical reactions. You don't have to memorize any of these, by the way, but it's nice to sort of have an idea. If we know that if you have these things occurring in a chemical reaction, it'll help you predict products. Here's a couple. You probably learned single replacement last year. Probably learned combustion, and here's a couple different types of those. For us, combustion is going to be perfect combustion, which means that for every organic molecule, it will be completely converted into carbon dioxide and H2O. In reality, if you're trying to burn something at home, in your car, your furnace, so forth, it's not always a complete combustion into CO2 and H2O. There are sometimes dangerous gases that you might produce, like carbon monoxide. So hopefully everyone's house has a carbon monoxide monitor, so that if this incomplete combustion occurs and it's not ventilated correctly, the monitor will alert you that there's carbon monoxide in the room, and so you guys can open your windows and so forth and get it checked out. Carbon monoxide is definitely a killer, for sure. And like I had mentioned before, those gases, or I guess H2O can be a liquid, if you have the potential to make those, you often will make those. And like I said, very short introduction to chemical reactions. We're going to start to go in a lot more depth in those for the rest of this Unit 4.